Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question. Today's question is tournament rigging. In this question, we are given two integers n and w and we need to construct an array A of length 2 raised to the power n plus 1 minus 1. So for example, if n is 4, then the length of the array should be 2 raised to the power 5 minus 1, which is 31. Now, the array constructed must satisfy these two conditions, which is A of 1 must be equal to W. So whatever the A of 1 is, that must be equal to W. For each I in bit from 1 to 2 raised to the power n, either A of I should be equal to max of A of 2i comma 2i plus 1, or it should be equal to min of A of 2i comma 2i plus 1. And the number of indices where A of I is equal to max of A of 2i comma 2i plus 1 should be minimized. And the last 2 raised to the power n elements must be a permutation of 1 comma 2 comma dot 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 2 raised to the power n. Now what all of it means is this is how our array should look like. This is a form of a tournament. So think of it as there are, let's say if n is 3, then there are 8 people in the bottom of the tournament who are competing against each other. And at every point, the adjacent people will be competing and the winner goes up, and then these will be competing and the winner goes up, and then these will be competing and this would be the final winner. So we want that this A of 1 must be the final winner such that for each of these elements, the number of indices where this A of 3 or any A of I or any of I is equal to max of A of, let's write it again. So the number of indices I where A of I is equal to max of A of 2i comma A of 2i plus 1 must be minimized. So this is what we need to create. Now let's just put in some values to understand it better. So let's say in the end, our final permutation is something like 1, 3, 4, 2, 6, 5, 8, and 7. Now at every index, either this A of 7 would be max of 1 comma 3 or min of 1 comma 3. So let's make it 1 for now. Let's make A of 6 to be 4, that is max of 4 comma 2. Let's make this to be equal to 5 and this to be equal to 7. Now let's A of 2 would be either max of 5 comma 7 or min of 5 comma 7. So let's make it to be 5 and let's make this to be 4. And the final answer would be 4, right? Now the number of indices where A of I was equal to max of A of 2 times I, comma, A of 2 times I plus 1. In this case is equal to 1 over here. 1 over here and 1 over here. So there are just two indices where A of I is equal to max of A of 2i comma 2i plus 1. And in general, our winner is W, like W is equal to 4. And in general, we just need to minimize the number of such indices such that the winner is a particular person. Let's just understand it better from these sample inputs. In the first input, we are given 1, 2, 3, and 4 are at the bottom or fighting. Then there is 3, okay, sorry, then there is 1, 3, and the final winner is 1. So in this case, the number of indices where any of them is greater, like equal to max of A of 2i comma 2i plus 1 is equal to 0, which is the minimum we can get. Hence, this is the answer. In the second, we have 1, 2, 3, 4, 2, 3, and 2. So in this case, the number of indices where A of I is equal to max of A of 2i comma 2i plus 1 is equal to just 1 at this index, right? So, and this is the minimum possible construction that we can have. There could be multiple construction and we can print any of them. In the third input, we have 3, 8, and we are printing, I guess, in the bottom level, there are 2, 3, 8, 1, 6, 7, 4, 5. Then there is 2, 8, 6, 4, then 4, then 8, 4, and the final winner is 8. So in this case, if we count the numbers, Then at this index, we are getting the min of both of them. At this index, we are getting max of both of them. So this is one index. At this, we are just getting the min. At this index also, we're just getting the min. At this index also, we're just getting the min of these two elements. At this index, we are getting the max of these two elements, right? And here also, we're getting the max of these two elements. So the total number of indices where a of I is equal to max of a of 2i comma 2i plus 1 is equal to 3, which is again the minimum possible you can get in this particular case. Again, if there are multiple constructions, you can just print any of them. Last one, you can just try it out for yourself, and I'll just move to the solution. Now let's just try to once see how what is happening, right? And just let us try to come up with one of the solutions. So if we have an array like something like this, 1, 2, 3, 4, 5, 6, 7, 8, if let us say this is a final permutation, then we either one will win or two will win, right? So it is better for us if we make one win, right? Because it's just pretty useless to make two win. We want four to be the final winner, so we have to make four win over here. We can make five win here. We can make seven win over here, right? Over here also, it's better to make five win. Here we have to make four win, right? And here also we have to make four win. So the total number of indices in this case is equivalent to two, right? One over here, we are making the bigger element win. One over here, we are making the bigger element win, right? Now, in optimally thinking, how would we be solving it, right? We just want the number of such indices to be minimized. So we just want 4 to pair up with a bigger element, right? So why not we just keep 4 in the beginning and then 5? So 4 will be paired with 5 initially, right? Then why not we just play 6 and 7? So 4 will be after once 4 wins, 4 will be competing with a bigger element, right? And now why don't we just place 8 over here and then just 1, 2, and 3? Now who would win? Here 4 will win, the smaller element. Here 6 will win, the smaller element. Here 1 will win, which is a smaller element, and here 2 will win, which is a smaller element. Competing these two, 4 will win because that is a smaller element. Here 1 will win because that is a smaller element. And in this case, 4 has to win. So this is the only index where 4 is equal to the max of these two elements, right? And this is ultimately the whole winner. And how many indices are there in this particular case? That is just one, right? And greedily speaking, it should be the best, right? It should be the most optimal strategy for us to follow. Just place the winner first, then place all the elements up till 2 raised to the power n, then just place all the elements left and then in an increasing order, right? And by following this strategy, we can ensure that 4 will be replaced by like minimum number of elements, right? We'll be just putting a of I equal to max of a of 2i comma 2i plus 1 minimum number of times because 4 has maximum possibility to pair with bigger elements, right? And that is pretty much the whole solution as well. Now, to construct the solution, what we can do is we can first of all create this as a computation and this as a final answer, which is very easy to build, right? We can just place 4, 5, 6, 7, 8, and then 1, 2, 3 inside a vector. And once we have pushed them, we'll just create the other arrays. So the overall size of our array would be 2 to the power n plus 2 to the power n minus 1, something like this, right? And in the last 2 to the power n elements, we'll just place something like this 4, 5, 6, 7, 8, 1, 2, 3. Then we'll just run from back to front and we'll see is either of them the winner, which we expect to win. If it is, then just place the winner. Otherwise, just place the smaller element. Now here, just place the winner. Otherwise, place the smaller element. Here, place the winner. And that's it, right? This is how we can just construct the whole solution. It will be much more clear once we see the code. So let's just see the code once. So this is the code in C++. We begin by taking in the input of the whole test cases. We take in the input of n and w for each test case. We define capital N to be 2 raised to the power n. We define the order. This is our last permutation of size 2 to the power n. We'll push all the elements from w to n inside this. We'll push in all the elements from 1 to w inside this. Then we'll create our answer vector, which will be of this much size, initially filled with zeros. We'll fill the last 2 to the power n elements with this order of I. Then we'll run in reverse order from n to 1. Now, if answer of I equal to 0, that means it's not defined yet. So if either the left child is a winner or the right child is a winner. We'll just put in W over here. Otherwise, we'll just put the minimum of both those elements. And in the end, we'll just simply print our answer vector and with a line break. And that's pretty much the whole solution. The time complexity of this is 2 raised to the power n plus 1 because we're running a loop of that much size. And that's it for this solution. Now let's see the solution in Python. So we run a loop for each test case. For each test case, we take in the input of n and w. We define capital N to be 2 raised to the power n. We just define the order to be all the elements from w to 2 raised to the power n. And then we'll just append all the elements from 1 to w minus 1. We'll define our answer to be some elements filled with zeros. And then this permutation, order permutation, right? Then we'll run a loop from n to 1. And for each element, if answer of I is equal to 0, then if either the left child is equal to W or the right child is equal to W, we'll just assign the current person to be W. Otherwise, we'll just set it to be the minimum of both the elements, and in the end, we'll just simply print our answer. Again, the time complexity would be 2 raised to the power n plus 1 because we're just running a loop of that much size. And yeah, that's pretty much the whole solution. I hope you liked it. Thanks. Bye bye.